Hi everyone, Kowalski here, and I'd like to welcome you back to our series on the 2025 Elastic CTF version 3. Let's the hunt begin. Now we are on challenge 14, and this is how it goes. You've identified the user account associated with a host under investigation. Now it's time to push further beyond lateral movement to uncover what else might have been happening during the same time frame. Now, our mission is to determine whether Johnny is acting as a rogue insider or his machine has been compromised. To do this, we have to one, disable the Kibana Alert Group ID filter in our query to widen the scope and uncover additional related alerts. So that means we have to write some sort of query to just pass all the logs to fulfill these exclusions that we have been faced with. Two, we have to exclude or disable the source IP address 198.51.100.100. And then we have to switch the data view to show only detection alerts, helping us to zero in on meaningful security events. That's interesting. So we have a lot of like constraints to implement, pass to our logs and see the relevant logs that we need to answer this question. Then we have to dig into the alert title, scanning and beaconing abnormal process args executed. And then we have to find the rare process argument this is associated with. So that is quite packed. Let's go into our credential theft space. Now, looking at our alerts, our alerts, sorry, um, we have to do some sort of filter to pass all the events so that we can have the relevant data that we are searching for to pass this or fulfill the requirements of this challenge. All right. Now, when you look at the placeholder in the filter text box, you can see that we have to filter using a KQL syntax, and KQL is Coastal Query Language developed by Microsoft. KQL, you see that it is a powerful read-only language used for exploring and analyzing large data sets, particularly logs and then telemetry. So we have to write some sort of commands in here which we will use in implementing those exclusions or constraints that we're passed with. So from the question, we have to look at the question and then implement those. So the first thing is one, we have to exclude the Kibana Alert Group Filter ID. All right. So that we will write it in this way. We say that not Kibana, not so that is a negative. So not Kibana, Kibana Alert Group ID. Okay. Then we just equate it, give it a value of a wildcard. That means everything. Then we also have to exclude the source IP address. Source IP address. Let me see. I think writing it here will even just make it work. So let's say that's what we're going to use. So not Kibana dot alert group ID, and then we give it a value. So that is the syntax, a wildcard. All right. So that will be the first thing we write. Then secondly, we say we have to also exclude the source IP address. So we do not the source IP and then give it a value of the IP address that we see here. So you, so let's give it this value. So that is what we need. So I'm building up the query, and then we just paste it in the search box. Now the last one, we have to look for a Kibana alert rule name, which has been given to us here. And give it the value that is given there. So I will just go paste this into our filter to filter out all these things that we don't need in our search to zero down in our query. So in here, this is what we built, and we can hit enter to update the logs. Yes, we might have some syntax error, but it looks like it's worked. So that is the filter in there. So the number of rows, we can increase it so that we can lower the amount of pages we have to visit in searching for our data. Great. Now let's start from the very beginning. Probably we see this what we're looking for and not have to scroll a lot. All right, so we give it time. It's loading. Okay, great. And these are the rules. So probably we should just expand this field to see clearly what you're looking for. And oh, I can see it quickly. Great. So this is what we're looking for: scanning and beaconing, alert, abnormal process, arguments, executed. Neat. So we go to viewing the full details of this alert, expand this, and go to the table. We can just, the problem is process arguments. So we can just search in the table to find a field, filter by the field process arguments. And we see that there has been some argument tags in here. If you can read this, that is a binary called Gotham scan, and then it is being passed to bash to run this. So let's see if that solves our challenge. So we hit this and we submit, and that is correct. So that solves our problem. So here we had to write some KQL to just filter out some of the logs that we do not need to focus on, the most important ones, and that is what we have been able to achieve. So thank you guys. I hope this has been informative and educational for you, and I hope to see you in the next one. Cheers.